Hey robot makers, do you want to know how to keep your Arduino Uno Q in tip-top shape? Then this is the show for you. So let's dive straight in. My name is Kevin, come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our couple of slides, and I'm going to get straight into the demo as well today. So there's 5 tips that you absolutely need to know about the Arduino Uno Q. So the very first thing that you may not know that you can do is you can plug in your one just here, your Arduino Uno Q, over a USB cable, and you can connect to it directly. You can actually access the shell. So let's see exactly how to do that. So you can access the Arduino Uno Q using a USB cable and a piece of software that's called Android Debug Tool. Now you might think, Android, this is running Debian Linux, why would we need to use Android? This is just a way that you can connect to devices over USB. Really simple to install. It's installable on all the main platforms, Windows, Mac, Linux, and it's also very simple to use. We'll have a look at this right away. So we're going to install ADB, going to do ADB devices, which will list any devices that are connected, and we'll do ADB shell, which will get us connected directly. So if you have your Arduino Uno Q, maybe you've not set up the Wi-Fi properly yet, maybe you just want to poke around, grab a file or something like that, this is how you can do that. So let's go and have a look at exactly that. So I'll have a bit of a demo. I'm just going to go to me for a second. I'm going to bring up a terminal. I'm just going to arrange my screen a bit better there so I can see what I'm doing. And I'm also going to make that a little bit bigger on the screen as well. There we go. Okay, so I'm just on my Mac. I've already got ADB installed. Now what I am going to do as well, I'm going to bring up my instructions. I've written all this up on kezrobots.com. A bit more about that later, about some of the other improvements I've made to kezrobots.com. But if I quickly switch over here, click on that article that's just there. It's kezrobots.com/uno-q-tips. And you can see that this is kind of what we're going to be going through today. So first of all, we're going to do this connecting up the cable. So we can actually see on here, I think this is like tip number 3 or something like that. Let me just find that on here. There we go. You can actually see, to do this on a Linux system, that's how you do it. Sudo install Android tools ADBD. If you're on Mac or Windows, there's other ways of doing this. So on macOS you can do brew install Android platform tools, and on Windows you can just download from developer.android.com/studios/releases/platform tools. Right, so let's get back to our window there, and the first thing we're going to do then is do ADB, Android Debug Tools, and we're going to say devices. And this is going to show me any devices that are attached and can kind of speak this language. That's the Arduino Q that we've got there, you can see. So what we can then do, we can do ADB shell. Oops, if I can type that right. And that gets us shell access. That little hash there is me connected directly now to the Arduino Uno Q. And if we type bash, for example, we get a more friendly shell than we would just through the very basic SH1 there. So we can do things like htop, we can see what's running on this Arduino, we can quit out of that, we can do all the usual kind of things like ls for listing all the files that are in the current directory. So it looks like we're in the absolute root. If we do cd home, for example, have a look where we are now, we're in the root home folder, and you can see that there's a folder that's called Arduino apps. So I'll show you a bit more about the Arduino apps in another tip in a second or two. But this is really great. This means that we can get access without having to have Wi-Fi connected, without having to have a keyboard or mouse. We can just plug it into a laptop, a desktop machine, just over a simple USB cable. So let me know what you think about that very first tip. Nice and simple one to get us started there. I'm just going to see if there's anything else I wanted to cover off on there as well. Yes, so you can push and pull files. So say you've got a file, let's go into that Arduino apps folder. I've currently not got anything actually set up on there, so why don't we go into the Arduino apps app, and let's create, so let's go for Harley is the one that I've got connected over USB. Now it does complain about this Linux being out of date. We'll get to that in a minute. We'll see if we can actually resolve that. Right, so I'm going to create a new app on here. Let's call this one test note 2, create new, and we'll just add, I don't know, to the Python file, just hello world to the live stream viewers. just so that we've got something saved on there. So if I now go back to that terminal window, let's do ls again. Which one am I on? Am I on Harley? So we should see that in there. So it's weird that we're not actually seeing that in there. I think it's because I'm in the root folder, and when I log in on the app that we saw before, we're actually logged into a user account that is called Arduino. So if I do ls, you can see there's an Arduino folder there. If I go into there, there's also an Arduino apps folder in there. And you can see we've got test 1 and test 2. So if I go into test note 2, have a look in there, there's a Python folder. Let's go into that Python folder and let's have a look at that main file that we've got there. And you can see that's the file that we just edited with the typos and everything on that other app. So that's where those files actually live. So if I wanted to grab that file and copy it over to my Mac, there's actually a command that I can use that will enable me to do exactly that. So let me just grab that. This is under the useful commands section on the write-up that I've done. So if I do ADB, the Android debug tool, and then I do pull, and the local file, if I do that, oops, so it's not, I need to exit out of here first. If I do ADB pull, and then that whole path that we've got there to that file that we want to actually grab onto our Mac. So if I do pull that /main.py, it's going to grab that file. And where am I at the moment? I'm just in my Kev folder. There should be in here a main.py now that we've just copied there, so you can see main.py. If I do cat main.py, I'm on my Mac. There's that file that we've just pulled back. So say we edited this file. Let's just edit that main.py. Let's correct that typo like that. Really important update there. And I want to push that back. Guess what the command for that will be? So it's ADB push main.py. And then we just need to say where we want to put that on the target device. So it's going to be that same folder that we did before. And it's pushed the file. So if we now go back into the app and we just change it to another file for a second. Maybe I need to close the app and then reopen it again just to get those updates to show through. You can see there that typo has now changed. So we can push and pull files from the Arduino, from the command line, using that ADB tool, the Android debug tool. So I thought it was a really cool piece of software. You might not have known about that. You can even reboot. If we do ADB reboot, we can actually reboot the Arduino. So it's gonna do exactly that. And we can see that the board is now going through its reboot cycle on here as well. Cool. I do ADB devices again. We can see that it's there ready to reconnect. Cool. So that's the very first one I wanted to show you. I'm just going to jump back to my keynote slides there. So the second tip is file sharing. So it's a little bit cumbersome doing the whole command line thing to get files on and off. It'd be much easier if we could actually set up file sharing on our Arduino. And we can do that. There's a piece of software that's been around decades for Unix computers, and it's called Samba. SMB is the name of the send message block protocol for sending files between machines. I think Windows had that first, if I'm not mistaken, and it's just how you see files on a Windows network. And Apple actually replaced their file transfer protocol, the Apple file protocol. Is it AFP, AFS, AFP? I don't know. I can't remember what the exact three-letter acronym for that one is, but yeah, Apple had their own one for years, but it was the classic kind of Apple operating system. And when they moved over to OS X, was it 20 years ago now, they also moved over to the SMB way of sharing files. That became kind of standard later on. So anyway, what we need to do is we need to install that. So let's get back over to our terminal. I'm going to log back in doing the ADB shell again. I'm just going to make this full screen so we can see it a bit easier. And it's going to do bash again because it's a nicer shell. And we're going to do sudo apt install. We'll talk a bit more about apt in a second. And we're going to install just Samba. You can do Samba and Samba utils as well, but this will get us what we need. So it's as simple as this to install. It takes about 20 seconds to install. We can set our stopwatches and see how quickly this installs. I think it's already got the packages downloaded as well, because I was testing this before the show, just so that I got this right for you guys. Right, so while that's doing that, I'm just going to scroll up to the top. And I've got some notes again on the write-up on kezrobots.com, so if you want to follow along with this, all the instructions are on there. There's just one file that we need to edit, and then one account that we need to add, and then we're ready to do some file sharing. So there we go, it's just doing all its updates. Okay, so the next thing that we need to do now that we've installed Samba is we need to set up what folders we actually want to share. I think it shares your user account by default. Let's go into the file and do sudo nano. Nano is our text editor, and then the following path, so etc. Samba, and then smb config. So I'm going to go into here, I'm just going to scroll down to the bottom, page down to the bottom of the file, and we can see here we can create a new share. So you do a little square bracket. I think this is called like an ini file. That's the kind of format of this. So Uno Q home, for example, turns green. It tells us it understands what that is. Then we're going to say path equals, and the path to our Arduino home. Then we're going to say browsable equals yes. So this means that we can actually find it if we open up like a network browser. Writable, make sure I've spelled that right, because if I spell this wrong it won't work, is yes. So we can actually write to the folder, it's not just read only. Guest access, we don't want guest access, we want to keep this reasonably secure. And then valid users, and then we can just say have a list of users, comma separated. So we're going to have Arduino as the valid user for this. That's all we need to do to set up file sharing. If you're not used to editing files, that might seem a bit extreme if you're used to just right clicking and things like that, but that's all we need to do there. So to make that now actually work, that file that we just done, we just need to restart the service. So it's system control restart SMB, and then we add a D on the end because it's a daemon, it's running in the background. We have daemons on our Linux systems, and then we also need to add an SMB user. So this is an extra step I always forget to do. So SMB password, we got the OR in there, -A for add, and then we're going to add the Arduino user, and we just need to type in a password so that we don't forget that. Right, so I can now go over to my Mac. I can go to connect to server, and I just need to know what the IP address of that is. So let me just jump back there. IPA, yes, it's still on 70. So if I come back over here, go to, this is on a Mac, connect to server, type in SMB : the IP address. That's what we need to do. I click on connect. It's going to ask me for my username in a second. Drag that down here so we can see. So it should ask me for like a username and password. If I've used this before, it may well be caching it. I'm not sure why it's taking so long to do that. It should pretty much connect right away. But that's simply how we install Samba. Of course, doing a live demo, things never quite work the way you expect them to. So I'm just going to wait for that to time out, I guess. Just going to double check that is the right IP address, because I need to make sure I'm on the same Wi-Fi network on both machines. So yeah, I'm on that one there. And if I do IPA and just grep anything that's got a 192.168 IP address, yep, IP70 is the only one that we need. So let's just try that again. Connect to server. Yeah, for some reason it's complaining about that. That's how we do it on a Mac. It's just frustrating it's not worked the first time, just to show you that actually working. So just assume that worked, and then you'll be able to browse the file system of that. I'm not sure why that is causing a problem. What we can do as well, I can set that up on the other machine. I've got two Arduino Uno Qs, so we could perhaps just set that up on the other machine. See if we have any success doing that as well. So we just go to terminal. So you can't see what I'm doing at the moment on this one. I'm simply, let's go to that view there, just logging into this machine, and let's do sudo apt install Samba on there. So yeah, this is also complaining about the update. Let's see if we can fix that a little bit later on, shall we? So I'm just going to type in my magic secret password for a second. So I just need to go off camera for a second on that one. There we go. Right, let's go back over that. And just yes to install. So this one hasn't got any of the files cached already. It's going to have to grab them off the internet, but it shouldn't have too much problems with that. While it's doing that, let's open up another terminal window and just see what IP address that is as well. So that is 160. So let me see if I can get over to IP address 160. I'll do that on another terminal window over here. So SSH kev, in fact Arduino at 192.168.1 dot, what did I say, 160. So it's just complaining about that IP address being used for a previous one. Is it SSH keygen? I can't remember the command to remove that. Right, let's try that again. Yes, to log in. Okay, so we're logged into that one. Good, that one's Arlene. There's Harley and Darlene, in fact. Wasn't Darlene a character on Roseanne back in the day? Right, I can see the machine. The other machine is nearly installed now. It's at 95%. Once that's installed, we'll do exactly the same Samba install on that one, just see if we can connect. I just want to show you what it looks like to browse around all the files and things, but then we can move on to the next tip after that one as well. Here we go. So I can just see it's finishing off installing on there, so that we can go back to the second terminal, and let me just arrange my screen a little bit there. There we go. Let's move that one off over there. Oh. Trying to make it so my face doesn't cover it up. Okay, so it's now installed Samba on the machine. So let's do sudo nano etc samba config. Yep. So Ford says indeed, Darlene was the name of one of the children in Roseanne. Oops. There we go. Let's page down to the bottom. And what I'm going to do, I'm actually going to cut and paste all of that. Copy and then paste. There we go, to speed it up a little bit. So instead of username, that needs to be Arduino. And the path also needs to be Arduino. Okay, let's just save that. Let's do sudo SMB password A and then Arduino. Type in the password. Okay, and then let's do that system control and then restart SMBD. Okay, and that's an IP address 160, isn't it? Right, okay, so what I'm going to do now is I'm going to go back to the Mac. I'm going to go to connect to server, and this time I'm going to try 160. And it should pop up with like a username and password. Yep, that's correct. So it's now going to ask me for a username. So the username on this one is Arduino. That's the account that we just added in SMB password, and then the password that we typed in. So hopefully once that's accepted that, we've then got a selection of what do we want to connect to. So Arduino is the one that you get kind of by default. That's the one that we set up in the terminal in that SMB conf file. So let's connect to that one. And we can now see that we have all these folders. So Arduino apps, they're all the applications that I've created using the Arduino app folder. So currently they only live on that one machine. So if anything should happen to that machine, it should get wiped or anything, I lose all that work that I've done there. So all those demos, that demo 3 that we did the other week, you can see the sketch files and everything there. So really important that we have a copy of them somewhere else. You can also see there the Geekbench preview files. I've got some downloads folder, documents, desktop, another Arduino folder for some libraries, pictures, public, thin client drives, video. So there's a whole bunch of things on there. There's even a Geekbench preview tar.gz. We'll have a look at what tar.gz files are also in a second as well. So that's the second tip. How do we set up file sharing, and then how do we access that? It's exactly the same to access that over a Windows machine as well. It just looks a little bit different from an interface perspective. So yes, we've done our installing of Samba. And tip number 3 is about backing up the Arduino App Lab folder, because if you don't back that up, you know, your files are literally just on that eMMC card on the Arduino itself. Anything should happen to that. If you use the Flash tool to upgrade the software that it keeps complaining about, you're at danger of wiping all the files that you may have spent ages creating. So let's have a look about how to do that. So we need to back up our files. That's the really important thing. And there's a Unix utility that's called tar, tape archive, and the GZ, which is the GNU zip utility. And those combined together can create you some really nice, simple to use backup files. And as a quick reminder about the 3-2-1 backup strategy, that's something that you should always apply to all of your computing devices. 3 copies of your data in 2 different storage types. One of them has to be off-site. So don't trust the Arduino Q as the only place where your projects live. At some point something will happen to them, and yeah, you're really at the mercy of other people's software and that device, you know, just not having any issues. You need to have 2 different types of storage. So backing your projects up to another machine is great. That means you've got at least 2 copies of the data there, but really you need 3 copies. So the last one is have a copy somewhere else. So somewhere not in your physical space where these things live, because if you had a fire or, you know, it gets stolen or something like that, all your work will have gone. So have a copy somewhere else. So that might be a cloud storage. It might be a NAS drive at another house that you replicate to using rsync or some Synology or Ugreen software, whatever. Could just be GitHub and some cloud storage. Definitely have 3 copies of your data. So let's do exactly that. I'm just going to scroll to the tip in my, I think it's tip number 2 on the right up there. So let's get back over to that terminal. So the easiest way to do this is actually using Git, I would say. So if you're familiar with Git, we can go into our Arduino folder. So we're in our Arduino folder, so let's just do ls. Let's go into the Arduino apps folder. There are all my projects. I want to copy all of those projects and put them into a Git repository. So Git is source code control software. Linus Torvalds invented this quite a while ago. So if we do git init, it's going to complain that I've not used Git before on this machine, so I just need to do some git config. I need to set up a global, I need to create a global setting for, oh, that's just talking about branch, so git branch, and then let's just call that main. I think main's what's used everywhere else. So if I do git status, so it can see currently these are all these folders and they're not committed anywhere, they're not being tracked. So Git isn't actually looking after those files. So we need to add all those files into our Git repository. Now we could do this by doing git, git add and then each folder one at a time, or we can just do git add and then full stop, and it will add everything, it will track everything. And essentially what it's doing is it's making a backup. It's copying all those files and then putting them in another place. It's putting them in a secret hidden folder. If we have a look on here, if we do that command, we can see that there's a .git folder. Now you don't normally look inside .git, we use the git command, but you can see there the description, info, hooks, branches, head, config, objects, index. Objects is where all the files are going to live, but they're going to live in a way that you can't easily access them. You need to use the git command to access these. So if we now do git commit -m, and then we give it a nice message, initial commit, for example, it's now created the backups of all them, and it's given that version that we have a name, so we can always get back to that other version. Now currently these are all sat just on this machine, so really what we want to do is copy that Git folder, and we want to make sure we have a second copy of that. So we can use this tar command for that. So this is tape archive. It's a very old Unix command when we used to have physical tape-to-tape reels, and the tapes would have to, they'd go to the very beginning, they would have an index at the beginning, they would find the file that they're after, and the file would say, you know, it's at block number something. We'd have to whiz the tapes on, trying to find that block, and then it would find the area, and then it would be able to write to that block. We don't have tapes anymore, so, or if we do, they're rarely used, I would say. So this is what we're going to do to create a tape archive. There's quite a few parameters on there. So I'm going to do -C to create. We're going to compress with zip. We're going to do verbose mode because we want to actually see all the files that we're backing up. We're going to do F because we're going to specify what the file name is that we want to back up to. So the file name is going to be called Uno Q-backup.tar.gz. So it's a tape archive, and it's using the GNU zip method, and then we need to give it the location. We can just say dot, just back up everything that's in there. You can see now it's now getting all those files, all that source code, everything, literally everything, and it's putting it into this file that we've now got, Uno Q backup.gz. And we can get that file and we can store that using that ADB command. We can pull that off here so that we've got a copy of it somewhere else. We could use the browsing the files that we looked at before, so we could go over to here. We can let's go into the Arduino apps folder. Do we have, am I on the right machine? There it is. So I can grab that. I can grab that into my downloads folder. I can go to my downloads folder. I can see it's a copy in there. It's 13 meg. If I double click on that, macOS knows how to open these up, and we've now got the backup of everything. So that's one way of backing up all your files. You can use lots of other different methods. If you use Git, you could actually push up to a remote Git repository such as GitHub. That's entirely possible as well. So that's one of the really useful commands. If we want to restore, so say I remove, I don't know, let's live stream app, for example. Let's just delete that. And we want to get back that folder. We've got no copy of it. You know, we're stuffed. How do we do that? So we need to restore. So if I do tar, and then we need to extract, decompress with GNU zip, verbose mode, and the file name. So we give it the file name, which is that Uno Q, blah blah blah, and then the restore location is also dot. So it's going to restore everything. If I now look in this folder, we've now got that live stream app folder back. So we've now restored everything. Phew, that was lucky, wasn't it? Cool. So that's tip number 3. Are we up to now? Cool. Tip number 4, keeping updated. Now I think this will address that issue that we have about the Arduino App Lab complaining that the Unix operating system isn't up to date. So let's have a look about how we can do exactly that. What do we need to do to update our Linux system and keep it updated automatically? If you're on a Windows machine, Windows Updates does this for you. If you're on a Mac, there is a software updates, I think it's called. Just grab that there. So yeah, under General and then Software Update. That runs in the background and it will tell you if there's an update pending, and you can just either schedule it or you can update right away. So it's a bit more manual on a Debian Linux system. We've got 2 commands that we can run. One will update the kind of local directory of, local catalogue, I should say, of possible updates. And that's for all the software that you've got installed, all the bits and bobs. So that's sudo apt update. Sudo apt upgrade will actually upgrade those existing packages. And if we do sudo apt install, we can actually install new software, just like we did to install that thingy-mabob a minute ago, which is the ADB. We could do that on the Samba, in fact. Sorry. Right, so let's have a look at a demo of this one. So this is how do we use apt. So what I'm going to do, I'm going to go over to our terminal again. I'm just going to minimize that folder there. Just so we've got this one on here that we can look at. Right, so if I do sudo apt update, this is on the Darlene one, which is the one that is actually asking for an update. Let's see if there are any updates pending that we can look at. So it's going to connect to the internet. It's going to connect to apt repo arduino.cc. It's going to see if there's any updates that are required there. And these are catalogues of all the packages that you have there. So it says 8 packages can be upgraded. So we can do sudo apt upgrade. And if we do -y, it won't ask us. If I just do it without the -y, at the end of this, running this command, it'll say, would you like to install these, yes or no? Now, you could actually put this command into some kind of script that runs in the background, but you've got this, it's going to be sat there waiting for a yes or no. So if I do the same command -y, it will not ask me for that. It'll just assume yes is the answer there. So you can see there all the different bits and pieces. It's now going to grab them. 123 meg to download, needs 115 megs to install, and you can see there all kinds of libraries and things and codexes being installed. Right, just going to see if there's anything else on that area that we need to cover off as well. So as well as updating packages, this is actually installing any security fixes that kind of become bundled up into each of these individual. You can see there, AppLab 1.2.8, which I think is much newer than the one I'm currently running on here. So if I go back over to this machine, I can see that we've currently got 1.2.3. Sorry, 0.1.23, so 1.0.28 is clearly the very latest version. And this message I'm getting on here, I'll just I can show you that any easier. It just says AppLab needs an update. So I think we can update this using this command. So it might take a little bit of time for it to do that, to install all these things. While it's doing that, we can go back to that other terminal that we just closed down there. We can run the same command on the other Arduino Uno Q. So apt update. Let's move that off to the side a little bit. And then on the other one, let's go back over here. It says, which services would you like to be restarted? The Arduino app command line interface service. Yes, let's get that to be restarted. That's fine. The other one only had 6 services that need to be upgraded. Let's do upgrade -y. And now I'm going to quit that that Arduino AppLab. I'm going to restart it and see if it complains about that Unix needs to be updated. Because in theory, we've just done the update. It should work fine. Let's see if it actually complains about that. I can see it's on 1.0.28. It hasn't complained about anything. But it has said, error checking for updates. An error occurred while fetching files. Please reload and try again. It probably needs a reboot. So we can do exactly that. So what I'll do over here, I'll just give this a reboot. I'll click on the logout and then the restart. It's really quick to restart, so this isn't going to be a problem for us. And I can also see there that the terminal window has just been, the connection has been disconnected. But that's fine, we can get it reconnected in a second. Meanwhile, the other one, that one has also done its updates. You can run these multiple times. So Martin is saying, why not full upgrade? So full upgrade, so great question. That is more reserved for operating system level changes, like when you go from, I don't know, Bookworm to Trixie, for example. We can type it and we can see what happens actually. So we do full upgrade. See if there's any differences there. It might be that the OS level patches get installed as well. There we go. So we've got a bunch of extra things being grabbed there. Let's see if it actually installs anything. Meanwhile, on the other screen, I can see that that's now booted back up over here. So if we go back over to this command here, we just log back in. Let's see if we have that message that we had before. Typing the wrong password in here. Right, so I have this thing that always happens with this computer. I always have cables dangling across the keyboard. It makes it really hard to type easily. I don't know if anybody else has that kind of issue. So I'm just going to log in here again. And let's see if we can have any different error messages. In theory, they should be. I wanted to do this live so that you could actually see if it makes a difference or not. So if anything does happen, you're seeing the experience that I see the first time I see it as well. Right. Okay. So I rebooted. We are still getting that error message there, error checking for updates, and errors occur. Please reload the application and try again. And I'll follow up with Arduino about that one. We did used to have a nice little icon on the desktop as well for the app lab, but it's hidden under accessories, which seems a really odd place. I'd have thought it'd be under development. There we go. So I'm just going to let that one connect there. We'll go back to this machines there. You can see that other one is busy doing its updates. And it does look like there are a few different changes since I last looked at this. There's a little run button I can see down here that wasn't there previously. And the second time it seems to be fine logging in. So this is able to start and stop the default app. So I can see on the screen there, we'll actually load up on the Arduino App Lab. So this is also on 0.1.28. And the run button on that one is at the top, but on the Linux version, the one I've just run on the actual Uno Q itself, this is actually at the bottom of the screen down here, and you can see that it says like start and stop and the name of the actual project that you've got running in the background. Cool. So what we can also do, there's another command on my little cheat sheet that says if you type in sudo system control status and then unattended dash upgrades. There we go. So nothing oh, need to type in my password. Yeah, unattended upgrades. Is that the right command? Yes, that isn't running, so that's fine. And if I go back over to there, I can see that the app that I created has now started, so I can move my robot backwards and forwards. If my battery was plugged in, that would be doing exactly that. So we can quit that. Nice user interface. And again, we can stop that down at the very bottom of the screen. This little stop button, that didn't used to be there. It's now there. That's a nice little quality of life update. The other thing I noticed as well, if I go into one of the programs, there's now a new folder on here that's called libraries. And that shows you all the sort of sketch libraries for the Arduino that we didn't used to have there. So that's a nice little quality of life upgrade as well that they've made there. Cool. So that's how we do updates. It did seem to stop complaining the second time when I logged the app again, so not sure why. Probably a little bug there. There seems to be a lot of rapid development going on with this, which is good to see because it means we're getting new features. But it does mean there's a lot of change happening. I did see some feedback from people on one of the videos about they didn't like the fact that when they plugged in their Arduino Uno Q that it was complaining about updates. It was brand new out of the box. They'd literally got it this week, and then the first thing is it says is it needs new software, and they found that to be like it didn't meet their expectations. It was kind of a poor experience from their perspective. But if you buy a Mac from an Apple vendor, you plug it in, guaranteed you'll need to do some software updates because the time between them shipping that out, boxing it up, you receiving it, new software is out there, new patches need to be installed. It's just one of those IT things. So that didn't surprise me too much that that had happened. Cool. Right, let's go to tip number 5. Oh, before we do that, if you like this video, you want me to make more videos like this, and particularly Arduino based videos, do let me know in the comments. If you want me to do other types of video, a lot of these tips are actually entirely compatible with Raspberry Pi as well, not just the Arduino Uno. So the space reclamation that we're going to look at in a minute, all the app updates, that's all applies to Raspberry Pi as well. So yeah, if you want me to make more Raspberry Pi type videos, do let me know in the comments as well. And if you want to subscribe to the channel, it costs you absolutely nothing. It means the world to me. Every time I get a new subscriber, honestly, my heart lifts. So if you want to make me a happy person, definitely give me a subscribe. And if you've not liked this video, do give this video a like. I think we've got 15 likes so far. There's 29 people watching live right now. So definitely smash that like button. Okay, so tip number 5, cleaning up space. So this is definitely something, particularly the Arduino Uno Q, which has got the 16 gig eMMC storage. You're going to run out of space after you've downloaded a few projects and you started to play around with this. Things just build up on there and you need a way of clearing out files. You need to be able to find them. We need to look at what happens automatically in the background from a maintenance perspective, and we're going to do some vacuuming. We're going to clean up some log files. So let's get over and do some of that right now. So how do we clear up space? So I'm just going to get my notes just to hand. Right, let's get back over to our terminal. So here we go. So let's do this. Close that one, minimize that. Let's make that a bit bigger. Right, let's just clear our terminal. So the first thing, the command that we need to know is df. This is like disk full. How much space have we currently got on our disk? And it's going to give you all the different file systems that are on there. Really, the main one we're interested in is this one that's just / the root. Now it's got a number there. That's the number of blocks. This is just like an arbitrary number. And really, we prefer to have human readable file sizes. So if you do -h and run that again, you now get megabytes, gigabytes, kilobytes, and so on. So this is a lot easier. So you can see there we've got 2 gigabytes available. We're currently using 6.9 gigabytes. That seems to be quite a lot of space used, given there isn't a lot going on there. You can see the home folders, we've got nearly a gig free there, so 915 meg available. We're using 2.5 gigs in our home folder. And then there's this boot EFI, is just some boot files and so on. So really, we're interested in this root and also the home folder. So that's on this eMMC block storage device there. So how do we find the individual files that are taking up space? So there's a couple of commands that we can run for that. The first thing that we can do, so the Arduino Uno Q uses Docker. So if we do Docker, we can see that there's a whole bunch of commands that we can run here, all these different commands down here. So there's rm for removing containers, RMI for removing images, and there is also some ls commands as well, so we can list. So let me just show you that. So if I do docker image ls, this will show me all the images and how much space they're taking up. So I can see there we've got the Python base, that's taking up nearly 800 meg. We have the Python apps base, that's a different version, that's taking up 700 meg. So we could clear these, and the next time we load the app lab, it will download what it needs. So we have to be patient that it might take a little bit time to download that, because it hasn't got what it needs. And it's got these cached on disk, so it's taking up a bit of space, but it means it's quicker. And it will, the app lab will also look and see, are we on the latest version? It might not necessarily clean up after itself. So if we want to remove some of these images that are taking up space here, we can do that with the command. So we do docker RMI for remove image, and then we just need to use the name of the image. Now let's just do, it's got autocomplete on here, so if I type in P for Python, you can see there that it's going to remove that that second one. That looks like it's the older one. So if I press OK, it's going to complain about that. Let's do sudo run the last command. That should work fine. It says it's being referenced by an image. So we can actually do an F. Sorry, let's do remove -F to force it. You don't really want to do -F unless you know what you're doing, but that's actually going to remove, it's untagged these bricks, and it's deleted that. So we've now got a bit more space back. So if we scroll up to where we did that ls command before, so let's have a look. So it's either going to be this one here, 2 gig, or this one, 915. So let's do df-h. So we've still got 2 gigs there, 915. So it doesn't appear to have made much difference there, where this is actually removed the files from. So unless it's just because it's rounding up, yeah, I would still have expected to see a difference there. Okay, so the other thing we can do docker, we can look at what volumes we have. So these are kind of like temporary storage areas. So sometimes if you use like the SQL brick or the influx brick, it may create a volume and store the data in those volumes. And again, it works the same kind of way. You can do volume rm and then the name of the file that you would see, the volume name that's on there. So we have images, we have containers. So let's containers ls. I think in fact we'll just do docker ps will show us what the running containers are. So currently 8 minutes ago, that's the one that it was running. This 555 is the name of the container ID, so we could actually remove that container if we wanted to. But the kind of catch-all command to do a cleanup from a Docker perspective is docker system prune -f, and what that will do is it will get rid of any images that are not currently being used. It'll get rid of any networks that are not being used. Networks are kind of a virtual network. So you can have two containers networked together, but with no outside connection. I don't know why you'd want no outside connection. We can see that it's deleted a couple of different networks that weren't being used, and we've not really claimed much space. But in reality, some of the stuff will have been removed there. Okay, so the other thing that we can look at from a space perspective is apt itself. The thing we did, apt update and upgrade. So when you do an update, it will update the catalog. It keeps a little cache of files that it's recently used, because if you install something, that might have an uninstall with it, and it will use that to remove the package. But all these things take up space. So when we do apt update, it will often tell you that there are some files that can be removed. So let's see if it tells us about that. And then we can do an auto remove to remove those unused packages. So let's see if there's any that we can remove there. So it's not actually telling us that there are any, so it's safe to run it anyway. So apt auto remove. You can do -y as well on this one if you want to say yes automatically. It didn't suggest that there were any that needed removing. There you go, upgrading 6. It's going to free up 117k. We'll have that. So it'll remove any packages or stuff that it didn't need. There we go. There you go. Type VNC. I tried installing this about an hour before the very first live stream that I did, and it totally messed up the demo. I couldn't connect to the machine. It just wouldn't load up the interface because I think it had installed X Windows instead of Wayfire. I don't know. It basically messed everything up, and I had to figure out how to uninstall that and update all the files that it had messed up. So that's the first command, apt auto remove. Then we can do sudo apt auto clean. So this will clean up any caches, any Debian files, .deb files that are hanging around, and there's an even more robust version which is sudo apt clean. I don't know why there's more aggressive, it says there. So if we now do df-h 2.2, so we've got some space back there, so that's good to see. We've got 200 megs of space back there. Now the other thing that will happen in the background is there are lots of log files that get created. If we do, I think a little var, which is like variable folder, all these log files, let's do -l to see the file sizes of these. So you can see we've got alternatives.log, alternatives.log1, bootstrap.log, we've got xorg.log, xlog.old, xorg1log, xorg1log.old, xrdplog, xrdplog1gz, so it's like a zipped version. These are all taking up space, albeit literally bytes, so it's not taking up very much space at all, but they are taking up space. So on a system that you're using quite a bit, some of these can get quite large, particularly if there is any errors that are occurring. So you might get like a messages or a system log that can get quite bulky after a while. Now on a regular Linux system that's running 24/7, there's scheduled tasks that run in the background. It's got a little note on them there. So there's one that looks at apt packages, so it runs daily, and it will refresh any available package information from the repositories, so it's a bit like doing a sudo apt update. That can happen automatically. Log rotation, so it'll go through these, there's a little cron job that will go through, and it'll compress an archival file. So these log.old and these gz, that's evidence of that cron job actually doing a bit of a tidy up, but it hasn't removed them, it's just kept them there. And typically these will wait until it gets down to like 9 or 10, and then it will remove the first one, and then everything sort of moves up a little bit, and you get a bit of space back. but it's still taking up space that you might need for a project. There are also man files, which are the manual files, and if you've ever used man on Linux, these are like manual files, so every single command, we do like man docker, for example, there's like a little help thing you can go through there, so it's like a little interactive help system. So there are updates to that database. There's a little cron job that occurs every week that will rebuild all the man files for your particular system. There's temporary files that appear in the temp folder, so if you do tmp, you can see there's some system private Bluetooth bits and bobs that are going on there. There is a daily job which will remove any of those temporary files, and then there's also package database cleanup that app runs periodically to get rid of old cache files. But we can actually step in and do a bit more active tasks. If we do du and we do sh and then var and then log, we can see let's do sudo. You might, when I get a command like that and it's complaining about permissions, we can actually do sudo, but rather than having to type in that command again, if I just do exclamation mark, it'll run the previous command but with sudo. So what this is going to do is it's going to look at the disk usage of all these files there. Sorry, 2 exclamation marks even. Well, that's going to run the previous one, which is not what I wanted. There's also the history command, just in case you want to find what number that is. So if I want to run sudo 276, if I do exclamation 276, it'll try and run that. If I now do sudo bang bang, it'll now run that command that I previously ran, but in the super user mode. And you can see there's a 44 megs worth of log files. So remember that 44 megs. We're going to try and squash down some of these log files. We can also search for really large files. There aren't too many. I have had a look at this already, so let's do log star, and then we're going to pipe that into the sort command. We're going to sort that by size, reverse order, and then we're going to pipe this into head -10. So it's going to look at just the, what have I typed wrong there? I've not typed in the disk usage. So we've only got that 44 megs of files, I think. So, oh no, there we go. So 42 is the largest one in journal, and then the rest make up the other 2 meg, which isn't terribly large. So that D package is one of the package logs. There's a Samba log that's been created, some other bits and bobs. LightDM is the window manager that we have there. So we can see there are some things that we can get rid of. So what we could do is we could do sudo journal. We know that this journal is taking up quite a bit of space there. And we can do journal control, and we can vacuum. Sorry, spelled with 2 U's, 1 C. And then we can say, get rid of anything that's older than 30 days. I don't think there is that much older than 30 days on here. We'll run that previous command again. So it's ambiguous. I think on here we need to do, sorry, it's size, is it? Let me just dash time equals 30 days. I think they've changed that slightly. So it's going to look and see if there's anything that's older than 30 days. So it has got rid of some bits. If we run that other command that we did before, it was 42 megs, wasn't it? So that's still showing us 42 megs on there. Not really very much has gone 30 days. Let's bring this right down to, say, 5 days. And see how different that is. There we go. So got rid of 29 megs worth of archived journals. So rerun that other command again. We should be able to see that 42 is now reduced down to 13 megs. Say our project still needs more though. We can be even more severe. We could make that down to, you saw before when I typed in vacuum and I pressed the tab key, there's a size option as well. So we can say equals, let's do 5 megs like that. So that's going to squash that journal down, and if we go back and do that again, we should see now that 13 meg is now 5 megs. No, that doesn't seem to have done that, but we can certainly get rid of the time down to like a single day, for example. There's another command that we can run as well. what that's done. So that's still staying at 30 megs there. So that must be in the last day that these have all occurred. So say that we actually want to squash down some files in a safe way. We can't just necessarily remove them, because if they're being written to in the middle of being removed, you might get a file in a sort of weird state. So there's a command that's called truncate. So truncate dash the size that we want to truncate it down, which is 0, and then the log file that's called syslog. So it'll make that file 0 in length. Let's have a look on var log. Let's do dash L. So syslog is now 0 size in length, which is good. Let's say that log1, we want to get that down to to 0. So it's called, so it's dpackage log.1, make that 0. It'll do exactly what we want it to do there. We now look at that dpackage log1, that's now 0 in size. So we can keep doing that if we want to. The other thing you can do, there is a nice little utility which, if you're as old as I am, there used to be some DOS utilities that was called Norton Commander. And Norton Commander was like a file system graphical user interface for the command line. And you can actually interactively see the structure of your disk and all the files that are on there, and then you could navigate them, you could copy files, delete them, and open up zip files, all that kind of good stuff. And so it's called Norton Commander, and I think there's a version on here which kind of copies that exact format. I think Norton as well, they were a company that the products were named after Peter Norton, as if he was like some person. They always had this person in like a white coat, like he was like some kind of lab person. But I believe it's just a complete marketing nonsense. He didn't actually exist as a person. Here we go. So you can navigate in a nice kind of user interface all the stuff that's going on your disk. So you can see that Arduino apps there. We can see we've got our zip file. We can get rid of that now, for example. Let's press D for delete. Yes, let's delete that. So it's a lot more interactive, but you do need to know what you're doing there so you don't delete anything that's critical. So I can get rid of that Geekbench, for example. Get rid of that one as well. Get rid of that old Xlog thing, that can go. D for delete, yes. You can tell I've used a Mac to browse this, because you get these horrible DS store files which are a bit like thumbnails.db used to be back in the day on Windows machine. There we go. So you can basically just see everything. That's ncdu. You just need to install sudo apt install ncdu. Okay, so I think that's everything from the clearing up perspective. So if you run this, you can definitely get some space back on your quite limited storage on your Arduino Uno Q. Cool. So I do go live as well every single Sunday. So we're now switching over to Greenwich Mean Time. So it was British summer time up until yesterday. We had an extra lie in bed this morning, an extra hour. Or in reality, we just got up an hour earlier than we expected and went shopping, and everybody else had done the same thing. You're going to follow me on Discord. We are still using our Discord community at the moment. So kezrobots.com/Discord. You can join that for free and sign up. It's completely free. And if you want to follow me on social media, I'm on all the social medias. I'm on Threads there. You can see Kevin McAleer at threads.net, Kevin McAleer 6 on TikTok, at Kevin McAleer on Instagram, at KevsMac on X, at KevsMac on Mastodon Social on Mastodon, and for Blue Sky, it's at kevsmac.bsky.social as well. So definitely give me a follow on all of those different platforms. And if you want to join the community, you can do that in a number of different ways. If you want to support the show, if you head over to kezrobots.com/coffee, you can donate for the price of a coffee as a one-off or as a regular thing. You'll find all the instructions at kezrobots.com/coffee. So there's a number of people who've done exactly that, and it's time to give them a shout out for doing this and being really awesome people. So thanks to Martin and Charles for buying some coffees. I really do appreciate them. And from the membership side, we've got Pietro, we've got Michael, Warren, somebody who wants to be anonymous, we've got Silicon Fiber, Marie, TKD, Jeff, we have DN Corti, Marlene, and Tom. And on the YouTube membership side, we have Shriva, that's how you pronounce your name, Shrishiva. And then we have Marie, we've got Pete, we have Dale from Hybrid Robotics, Oxrad39, Warren, Brian, Pieves, we've got Bert, Michael, Stephen, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Johnny and Tom. So thank you all for really helping support the show. It's been really useful to me over these past couple of months while I've been in between contracts, as they say. So it meant I could actually get another Arduino Uno Q, for example. Cool. So let's just jump back to the keynote there. So the little spinny logo tells me it's at this point in the video where YouTube will be recommending over here another video for you to watch. Definitely check that one out. Let me know what you think in the comments. All those extra views really do help the channel growth. So if you like what I do, watch more of the stuff, and it'll just help the YouTube algorithm. So thank you so much for watching, and I shall see you all next time. Bye for now.